features of equilibrium constant. The first feature is equilibrium constant is applicable only when concentrations of the reactant and product have attained their equilibrium state. For example, the reaction N2 plus 3S2 reversible 2NH3 is in equilibrium state inside the vessel. The second one is the value of equilibrium constant is independent of initial concentrations of the reactant and product. For example, the reaction PCl5 reversible PCl3 plus Cl2. For the case 1, initial concentration of PCl5 equals to 3 and that of PCl3 and Cl2 equal to 0. At equilibrium, concentration of PCl5 is 1.41 and that of PCl3 and Cl2 is 1.59. So, the Kc of the reaction is 1.8. For the case 2, let initial concentration of PCl5 equals to 8 and that of PCl3 and Cl2 equals to 0. So at equilibrium, the concentration of PCl3 equals to 5 and that of PCl3 and Cl2 equals to 3. For this case also, Kc equals to 1.8. The third one is equilibrium constant is temperature dependent, having one unique value for a particular reaction represented by a balanced equation at a given temperature. Let's take limestone, that is CaCO3, in a beaker. Now cover the beaker and heat it. Remove the burner before the temperature reaches 50 degrees centigrade. We can observe that CO2 is released and CaO is formed. The reaction taking place is CoCO3 on decomposition gives CaO plus CO2. Now let's heat the beaker again. We can observe that reaction moves in forward direction and more CO2 and CaO is formed. Conclusion. At equilibrium, the concentration of the reactant and product depends on temperature. The fourth one is equilibrium constant for reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. For the reaction 4NO plus 6H2O reversible 4NH3 plus 5O2. The equilibrium constant for this reaction is equals to concentration of O2 to the power 5 multiplied by concentration of NH3 to the power 4 upon concentration of NO to the power 4 multiplied by concentration of H2O to the power 6, which is equals to 1 upon Kc. The fifth one is, if we change the stoichiometric coefficients in a chemical reaction by multiplying throughout by a factor, then the equilibrium constant is raised to the power of that factor. For the equilibrium reaction 4NNH3 plus 5NO2 reversible 4NNO plus 6NH2O. The equilibrium constant for this reaction is equals to concentration of NO to the power 4N multiplied by concentration of H2O to the power 6N upon concentration of O2 to the power 5N multiplied by concentration of NH3 to the power 4N, which is equals to Kc to the power N.